Okay, guys, we're going to continue with percentages today. So it says, use a benchmark to find an equivalent percent for each fraction. You should have seen benchmark fractions in the video on Friday, but benchmark means like one you're familiar with, like fractions, 1/4, 1/2, 3/4, 1/3, 2/3, and then the percentages that go with those. So if we have 9, let's start with 9/10, like number 2. It says use a benchmark to find equivalent percent for each fraction. Well, I can just set this equal to 100. How do I get from 10 to 100? I'm going to multiply by 10. Then I need to multiply 9 by 10, and I would get 90. And 90 out of 100 is 90%. You could also say 9/10, that's 9 of these 1/10, right? And so it's 1/10 9 times, okay, which would be the same as 90 over 100, okay? Because 1/10 is 10%. So if you have 9 of those, if you multiply that by 9, you're going to get 90%, okay? I prefer to use the part over whole equals percent over 100. So again, that's going to look like this. My part over my whole equals my percent over 100. I can cross multiply here and say 9 times 100 is 900. 10 times x is 10x. I would have to divide by 10 on both sides to isolate x. 900 divided by 10 is 90x, so it's 90%. Okay, so there's a few different ways that we can solve that one. Okay, let's look at this one. Mark wants to use a grid like the ones in exercise 1 and 2 to model the percent equivalent of the fraction 2/3. How many grid squares should he shade? What percent would his model show? Well, what they're talking about is a hundreds grid here, okay? And so if you are going to have to shade 2/3 of it, well, I have 2 over 3 is equal to a percent over 100. I'm going to cross multiply, so I'd have 3x equals 200. I have to divide by 3 on both sides. When I do that, you're going to get 66 2/3%. That means that you would shade 66 2/3 of the squares on the hundreds grid. Okay? Or if you pop that in a calculator, it's going to be 66.667%. Okay? Here they want to know which one is the greater quantity. Well, we have to convert them both to percents or both to fractions in order to compare them. So if I have 1/3 and I want to convert that to a percentage, I'm going to set it up as part over whole. So here, remember part, I should have probably said that earlier, over whole equals percent over 100. So I'm going to let that be there. That was the whole focus of that video on Friday. So again, I'm going to cross multiply. 1 times 100 is 100. 3 times x is 3x. If I divide by 3 on both sides, I end up with 33.333 equals x, which is 33.333%. 50% is definitely bigger. The other way that I could do this one is look at 50%. Well, 50%, remember percent means out of 100, so it's 50 over 100. And if I can reduce that, I can divide by 50 over 50. I'm going to get 1/2. And 1/2 is definitely bigger than 1/3. So either way would work for that one. It wants us to use this percent model to find the missing percent. Well, here we have 8s, right? So this is going to be 2 8s, which is the same as 1/4. This is going to be 3 8s, right? This is going to be 4 8s, which is the same as 1/2. It's going to be 5 8s. This is going to be 6 8s, which is the same as 3/4. And then this is going to be 7 8s. Okay? So in order to get the percentages, well, we know this one is 25%, right? So you know this number has to be between 25% and 0. Well, I can set it up as part over whole equals percent over 100. I have 1 for my part, 8 for my whole. I need to find the percent. So I'm going to cross multiply. I'm going to get 8x is equal to 100. I need to divide by 8 on both sides to isolate x. I'll get x is equal to 12.5%, or 12.5% in your calculator. Okay, so that would be the answer. 17, Marcus bought a booklet of tickets to use at the amusement park. He uses 50% of the tickets on 1/3 of the rides. I'm sorry, let's read that again. Marcus bought a booklet of tickets to use at the amusement park. He used 50% of the tickets on rides. So I'm going to write that down. 50% went to rides. 1/3 of the tickets went to video games. And then the rest went to the batting cage. See, I would spend more of mine on the batting cage, I think. Marcus says he used 10% of the tickets in the batting cage. Do you agree? So we want to know, is 10% in the batting cage correct? Well, the first thing I want to do is convert 1/3 to a percentage. We just did this on the previous problem. So in order to do that again, part over whole equals percent out of 100. Here I have 1 is my part, 3 is my whole. I need the percent out of 100. I'm going to cross multiply. And then when I divide by 3, I'm going to get 33.333%. Okay, so entire whole of something equals 100%, right? So if he spent 50% on rides and then 33.3333% on the video games, I'm going to add that up. I get 83.333%. Well, I can tell now that Marcus is not correct. He cannot have only spent 10% on the batting cage, because if I add 10% here, I'm going to get 93.333, and it has to be 100%. So our answer here is going to be no, it's more than 10%. Oh, I'm sorry, it's less than 10%. I messed up there. It's less than 10% because 100 minus 93.333, it's going to be like 6.77%. Okay, so here the answer is no, he spent less than. Oh no, I messed that up again. Oh, I'm so sorry. Now look, I added that and only got 93%. I need more to get to 100. I'm so sorry, you guys. So I definitely need to take 100 and subtract 83.333 from it. Okay? When you do that, you can just pop that in your calculator. You're going to get 16.667%. So the answer is no, he spent 16.667% at the batting cage. Sorry about that little goof up there. I was going a little fast. See, you guys need to slow down and make sure you check your work so you don't end up like your teacher. Okay, last one here, okay? So there's a pattern here. So they're telling you 1/5 is 20%, okay? So then they're saying 2/5 is how much? 3/5 is how much? 4/5 is how much? 5/5 is how much? 6/5 is how much? Well, this is pretty easy to do. You can make equivalent fractions here pretty easy. So I have 2 over 5 equals, now I can do percent over 100. It's going to be the same thing because I'm going from 5 to 100. I just need to multiply by 20. This is friendly. So this one is 40%. Okay. Then if I have 3 over 5, I'm going to take it to something over 100. again, multiplying by 20, I'll get 60%. So this one is 60%. And then if I have 4 over 5, I'm going to set it equal to 100. It's still friendly. I'm still multiplying by 20. I'll get 80%. Now, 5 divided by 5 is 1. 1 times 100 is 100, so that's 100%. If you have all of it, so 5/5 is all of it, that's 100%. You don't even have to work that one out. I know that doesn't sound like me either. And this one is still friendly, even though it's improper. I'm still multiplying by 20, and I'm getting 120%. You can have more than 100%, remember. Okay? So what is true when the numerator and the denominator of the fraction are equal? Well, it's 100%, because it's all of it. And then they want to know what is true when the numerator is greater than the denominator. It means it's more than 100%. Just like if it's an improper fraction, it's more than 1. Here, it's more than 100%. And then down here, what is the percent equivalent of 3 over 2? Find a pattern like the one in the table to support your answer. Well, if I go 3 over 2, I set it equal to something over 100, because percents are out of 100. From 2 to 100, I multiply by 50. 3 times 50 is 150. So this is 150%. Okay? That was pretty easy. Okay, so there's your video lesson. You're going to have 4 problems on a formative to complete for today. Okay, thanks guys.